for example, I remember that, you know, if we would use this printer in space, you know, what opportunities are here, especially when it comes to, you know, yeah, let's stick to the sci-fi world, I would say, because I think that's like easier for the people also to understand.
I think you're going a little bit ahead of what I was supposed to say, but that's fine. I like your enthusiasm.
Yes, yeah.
So I didn't mention, but you just bring in the point that indeed this technology can work also in space, and we came up to this thought after analysis, even after the first year of developing our prototype. And when we realized this, we contacted NASA, later ESA, and suddenly we found people who were interested in these organizations. We built even the first prototype. We delivered to NASA. We sold the first prototype. An idea that we want to bring this first prototypes into space, or first zero gravity test, and then to ISS, to exactly demonstrate that it can work in space. The benefit of this technology in space, that with the gases, you can direct them with a pressure any direction you want, and they are not like liquid or solid material that will fly at zero gravity in the whole compartment, and you cannot catch them. With the gases, you can easily catch them. The gases are used as the thrust for directing satellites and rockets to the orbits even. So this is basically the same type of technology. So what you can do with these pure materials that you get from gas phase materials, you can build atomic layers. Why you need atomic layers in space? Because basically one way of benefit is that you can start prototyping devices for in-space missions. Like, let's say you send scientists to make some biomedical experiments, testing how the cells growing in space, and you need organ on chip, let's say brain on chip, and see how the behavior of the cells happening in space, because you have zero gravity and you don't know how they would grow, stem cells. And here you can print your own test micro device, microfluidic device, or other type of device, and then you can easily iterate. You can change this, because delivering some sensors or devices from Earth to space, even with Elon Musk SpaceX company, it's still expensive. And there you will have the device, the nanofabricator, that will do this job for you. Another opportunity is, let's say, now we're targeting for Artemis mission to set up a base on Moon or even on Mars. The travel time, especially for Mars, is half a year, and you have a lot of rocks around, and probably even gases underneath, under the core, under the rocks. And what you can do, you can set up your own decentralized, on-demand manufacturing of any component you want. And if we look even further on, like long-term missions, I think in 50 years we might even dream about this, not even dream, coming to close to implementation of this. So we need technologies that will create manufacturing on a longer travel missions. This is a standard 3D printing. This is our technology, atomic layer manufacturing. This is other type of additive manufacturing technologies. And this gives a freedom to innovate and bring necessary parts to the infrastructure.